solution sets of two or more inequalities joined by and or. And this is very similar to the lesson that we did yesterday, where we talked about equations joined by and or. So what we're going to look at first is exercise 1. It says solve w squared is equal to 121 for w, and graph the solution set on a number line. So what we're going to have to do first is we're going to have to solve for w. So let's start with w squared is equal to 121. And if we have w squared and we want to get w, we're going to have to take the square root of both sides, because the opposite of square is square root. And when we take the square root, we have to take both the positive case and the negative case. So if we get w is equal to, the square root of 121 is positive and negative 11. And so looking at that, that is our solution. We have w is equal to 11 and w is equal to negative 11. So now if we draw our number line, on our number line I'm going to go from negative 15, and then I'm going to go up by 5s. Negative 10, negative 5, 0, 5, 10, 15. And if we start with w is equal to negative 11, we go over a little bit to the left of negative 10, and we fill it in because we do have equality. So we have a closed circle there. And above it we could just put negative 11, so that we know that at that point is negative 11. And then we go to 11, fill it in with a closed circle, and make that 11. And we're done. Now we're going to use what we just did in exercise 1 here, or number 1, and we're going to solve for w squared is less than 121. So let's start by writing that down. It's less than 121. And now what we have to do is we have to, again, take the square root of w squared, square root of 121. But now when we take the square root of 121, we're going to have the positive and the negative case. And in the negative case, we're going to have to flip the inequality sign. So we're going to have that w is less than 11, and now we have to flip the inequality sign. W is greater than negative 11. So now if we wrote this, they want us to write it as a compound inequality. We can write this as a compound inequality by getting rid of and just writing it as negative 11 is less than, w is less than 11. And then on our number line, I'm going to draw the same number line as I did in the last example. So negative 15, negative 10, negative 5, 0, 5, 10, 15. And then we have, since we have less than, or greater than, and less than, what we're going to do is we're going to have an open circle. So at negative 11, we'll have an open circle because 11 or negative 11 is not included. And then we have an open circle at 11. So again, above it we can write negative 11 and 11, so that we can see that those points are negative 11 and 11. And then where is w greater than negative 11 and less than 11 is right in between. So we're going to shade in between the two inequalities. And then there we have it. So now what we can do is we can also solve w squared is greater than or equal to 121. So let's do it the same way. So we have w squared is greater than or equal to 121. And if we want to solve that for w, we're going to have to take the square root on both sides. Okay? And then we're going to get that w. And then since we have the positive and the negative case, so we're going to say that w is greater than positive 11, and w is less than or equal to negative 11. So then we have both cases. And if we wanted to write it as a compound inequality, we would use or. So we have w is greater than or equal to 11, or w is less than or equal to negative 11. And then on our number line, I'm going to write the same number line, negative 15, and go down by 5s, negative 10, negative 5, 0, 5, 10, 15. Okay, and then let's start with 11. W is greater than or equal to 11, so at 11 I have equality, so I'm going to fill it in and mark that that's 11. And if it's greater than or equal to 11, we're going to go to the right. So we shade in to the right. And then we have negative 11, so I'm going to have equality, because W is less than or equal to negative 11. And then I'm going to go, since it's less than, I'm going to go to the left. So now what we could do is we can use all three of these examples and we can quickly solve x plus 7 squared is equal to 121 for x. And it says graph the solutions on a number line. So if we wanted to quickly do this, we know that when we take this, we're going to have to take the square root of both sides, and we're going to get that x plus 7 is equal to negative 11, and we have x plus 7 is equal to positive 11. And in both cases, we can subtract 7 on both sides. And I'm going to get that x is equal to negative 18. And x is equal to 4. And then all I have to do is just put those solutions on my number line. So again, I'm going to take my number line, negative 15, negative 10, negative 5, 0, 5, 10, 15. And then what I'm going to do is I'm going to plot or point on a number line. So we have x is equal to negative 18. So negative 18 would be somewhere over here. Above it I'll put negative 18. And x is equal to 4. So right before 5 we'll have equality. So we're going to fill in our circles to have 4. Okay? So now what we're going to do is it says use the work from part 4 to quickly graph the solution of a number line to each inequality below. So again, if we have x plus 7 is squared is less than 121, we can solve it by using what we have here. So we know that we're going to have x, and if we have, since we up here we use our negative 11 case, we are going to get that x is greater than negative 18, and x is less than 4. Okay, and then to do that, so if we have x is greater than negative 18, but x is less than 4, on my number line, so I can just start here, I guess, with negative 20, and go down by 5s. Negative 15, negative 10, negative 5, 0, 5, 10, and 15. So looking at this, if I have x is greater than negative 18, so at negative 18, I'm going to have an open circle at negative 18. And at 4, I'm also going to have an open circle. And then we're going to have that x is greater than negative 18. So where is it greater than 18? It would be to the right. And x has to be less than 4. So at 4, it's going to be less than. So where does both of those inequalities work? Right in the middle. So we're going to shade in the middle. Okay? So now looking at the next one, we have x plus 7 squared is greater than or equal to 121. And we can use exactly what we came up with. So we have 4 and negative 18. But remember, with our negative case, where you have the negative 11, we have to flip this inequality sign. So we're going to, let's do our negative case first. So if it's greater than or equal to, we're going to flip it, and it'll be less than or equal to, and then it'll be negative 18. Or we can have that x is greater than or equal to 4. Okay, so on our number line, at negative 18, we're going to have a closed circle because we have equality. And then at 4, we're also going to have equality. But in this case, x is less than or equal to negative 18, so we shade into the left of negative 18. And then we have x is greater than or equal to 4, so at 4 it's going to be greater than, so we shade to the right. Okay? Then, let's move on to our next example. So let's look at exercise 2. Exercise 2 wants us to consider the compound inequality, negative 5 is less than x is less than 4. They first want us to rewrite the inequality as a compound statement of inequality. And if we have something like this where it's one long inequality, we can break it up with the word and. So we have that x, so reading from x, x is greater than negative 5. So x is greater than negative 5, and x is less than 4. So there's our compound statement of inequality. And remember that we just used the word and, not or. So it says to write a sentence describing the possible values of x. So if we look at this, x can be any value between negative 5 and 4. And that's what this has up here. That x has to be greater than negative 5, and x also has to be less than 4. So to write a sentence describing the possible values of x can be any number between negative 5 and 4. And then if we wanted to graph that on our number line, we would have at negative 5, we're going to have an open circle because we don't have equality. And then at 4, we're also going to have an open circle. And where it's x greater than negative 5, but x is less than negative 4, it would be in between our 2 points. So we can shade in between our 2 points. Okay? Let's move on to exercise 3. Exercise 3 now, it says consider the compound inequality, negative 5 is less than 2x plus 1 is less than 4. So to rewrite this, we're going to rewrite the inequality as a compound statement of inequality. Well, let's just break it up. So we know that 2x plus 1, and then reading from it, we have that it is 2x plus 1 is greater than negative 5. And then we also have that and 2x plus 1 here has to be less than 4. Okay? And then for part B, now that we wrote our compound inequality, now we can solve the inequality for x. So if we wanted to solve the inequality for x, we take 2x plus 1 is greater than negative 5. And let's solve that one first. So to solve that one, we're going to use the order of operations in reverse. So if we're adding 1 on both sides, we're going to subtract 1. Subtract 1. It will cancel. We'll get 2x on this side is greater than 5. Negative 5 minus 1 is a negative 6. And then if 2x is greater than negative 6, we can divide by 2. Divide by 2. And x is going to be greater than negative 3. Okay? And now let's solve the other one. So we have 2x plus 1 is less than 4. So let's write that down. 2x plus 1 is less than 4. And then we're going to use the same steps to solve it as we did in the other inequality. So we're going to subtract 1. Subtract 1. We get 2x is less than 3. And then to get x, if we have 2x, we're going to divide by 2 on both sides. And then we get that x is less than 3 over 2. And in this case, we look at it, and we want to write a sentence to describe the possible values of x. Well, x has to be between negative 3 and 3 over 2. And 3 over 2 as a decimal, we could say that that is the same thing as 1.5. just so on our number line we can figure out where we're going to put our point. So now we have to write a sentence describing the possible values of x. So again, since we have that 2x plus 1 is between these two values, for our answers, x has to be between these two values. So x can be any number between -3 and 1.5. Or we could say 3/2. Okay? And then looking at this, we want to graph the solution set on the number line below. So x has to be greater than -3. So at -3, we're going to have an open circle at -3. And then we have at 1.5, we're also going to have an open circle because we don't have equality. So halfway between 1 and 2, we can have an open circle. Above it, we can put that as 3/2 or 1.5, whichever you prefer. And then between it, so we're going to shade in between the 2 points. Okay? And then if we go back to B, we have to write the solution to the compound inequality. If they wanted us to write it in a compound inequality, x has to be between, so we would write it as -3 is less than x is less than 3/2. And then there's our solution. Alright, now let's move on to exercise 4. For exercise 4, it says given that x is less than -3 or x is greater than -1, they want to know what must be true in order for the compound inequality to be a true statement. Well, first one we have to look at what would make it a true statement, whether we used or and. In this case, we use or. So remember with or, only one of the statements need to be true for the whole statement to be true. So what must be true? We can say at least one statement needs to be true for the compound inequality to be true. So in this case, x has to be either less than -3 or x has to be greater than -1 for this whole compound inequality that we have to be true. So now if we describe the possible values of x that it can be, we could say that x can be, so if we first look at x is less than -3, so we could say that x can be any number less than -3, or now we could look at x can be greater than -1, or x can be any number that is greater than -1. Okay? And if we look at this, when we're graphing it out the solution set on a number line at -3, since x is less than -3, we're going to have an open circle at -3. And if it's x is less than -3, we're going to go to the left. So we're shading to the left. And now let's deal with the other one. X is greater than -1. So at -1, again, we're going to have an open circle. And then if x is greater than -1, we're going to go to the right. So we would shade to the right. And then there's our whole exercise. So now let's move on to exercise 5. It says given that x plus 4 is less than 6, or x minus 1 is greater than 3. They want to solve each inequality for x and then write the solution to the compound inequality. So if we look at this, we're going to start with x plus 4 is less than 6. In order to solve for x, what we're going to do is we're going to have to subtract 4 on both sides. So on both sides, since we added 4, we're going to subtract 4. So we're going to get that x is less than 6 minus 4 is 2. So then what we have to do is we have to look at the other case now. So we have x minus 1 is greater than 3. And then to get what x is, what we need to do is we need to add 1 on both sides. So we get that x is greater than 4. Okay? So those are our two solutions that we have. And now what we're going to do is to write our compound inequality, we're going to use the word or, because that's what they used up here. So if that's what they used, then we could write that our compound inequality is x is less than 2 or x is greater than 4. And then that is our solution. Now if we wanted to write a sentence describing the possible values of x can be any number. We could say that x can be any number less than 2 or it could also be x could be greater than 4. Okay. So on our graph now for part C, when they say graph the solution set on the number line, what we need to do is we need to look at, first let's start with x is less than 2. So let's start at 2. So we're going to have an open circle because we don't have equality here. We just have less than. And then if it's less than, we're going to shade to the left. Or, remember that x could be greater than 4. So at 4, we're going to have an open circle because we don't have equality there. And if it's greater than, it'll move to the right. Okay? And that's our whole exercise 5. Okay, so now what we're going to look at is exercise 6. On exercise 6, it says to solve each compound inequality for x and graph the solution set on a number line. So let's go through and do that. For A, it says x plus 6 is less than 8 and x minus 1 is greater than negative 1. So let's go through and solve this. So we have x plus 6 is less than 8. So let's go through and solve this one first. So what we have to do on both sides, since we have x plus 6, we're going to subtract 6 on both sides. So we get that x is less than 8 minus 6 is 2. So x is less than 2. And now we're going to solve x minus 1 is greater than negative 1. So now to do this, what we're going to have to do is we're going to have to add 1 on both sides. So we get that x is greater than negative 1 plus 1 is 0. So now what they want us to do is they want us to graph this inequality on a number line. So if we draw our number line, so over here I'll draw my number line. And we know that we have 2 and 0 on it, so I'm just going to start with negative 2, negative 1, 0, 1, 2, 3. So now looking at this, let's graph x is less than 2. So we go to 2, and since x is less than 2, we're going to have an open circle at 2. And then at x is greater than 0, so we'll go to 0, and we'll graph our open circle. And whereas x less than 2 and x is greater than 0, it would be in between 0 and 2. Okay? So now let's go on to B. For B, we have -1 is less than or equal to 3 minus 2x is less than or equal to 10. So in this case, we could break it up for this first case and then break it up into our second case. So let's start with our first case. We have that -1 is less than or equal to 3 minus 2x. And then in this case, what we would want to do is to get x by itself, we could subtract this 3 on both sides. So 3 minus 3 would cancel. -1 minus 3 is a -4. It's less than or equal to -2x. And then here what I'm going to do to get x is divide both sides by a -2. Divide by a -2. -4 divided by -2 is a +2. But since we divided here by a negative number, because remember when you multiply both sides or divide both sides by a negative number, you have to flip this inequality sign. So instead of less than or equal to, it'll be greater than or equal to x. Okay? So there's one solution to our inequality. So now let's look at 3 minus 2x is less than or equal to 10. So let's take the other case. 3 minus 2x is less than 10. And we're going to use the same steps that we just did over here, except for we'll just have a different number. So here, we're going to subtract 3 on both sides, subtract 3. So we're going to get that -2x is less than or equal to 10 minus 3 is a 7. And then on both sides, to get x, if we have -2x, we're going to divide by -2. Divide by -2. So we're going to get x on this side, because -2 will cancel with -2. And since we divided by -2, we have to flip the sign. So let's flip the sign to be greater than or equal to. And then we'll have -7 over 2. And -7 over 2 is the same thing as 3.5. -3.5. Okay? So then on our number line, so I'm going to draw my number line over here. So on my number line, I'm going to go, I have 2 and I have -3.5. So let's just start with -5. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So we went from -5 to +5. And now when we graph this, we have x. So reading from x here, x is less than or equal to 2. So at 2, we're going to have a closed circle or filled in circle at 2. And at x is greater than or equal to -3.5, so about halfway between 3 and 4. Again, I'm going to have a closed circle, and then above it I can write -3.5. And since we have this double inequality here, we would use and. So we want to see where they are the same. So what we need to do is between -3.5 and 2 is where we want it to shade in. Because we want x to be less than or equal to 2, and we want x to be greater than or equal to -3.5. And that's what we just did right there. All these numbers in between -3.5 and 2 are solutions to this inequality. Now let's move on to part C. We have 5x plus 1 is less than 0, or, so now we're using or, 8 is less than or equal to x minus 5. So if we look at this, let's start with 5x plus 1 is less than 0, and let's solve this one for x. So what we're going to have to do is we're going to have to subtract 1, and then we get that 5x is less than 0 minus 1 is a -1. And then to get x, if we have 5x, we're going to divide both sides by 5. So we get x is less than -1/5. And then we also have 8 is less than or equal to x minus 5. So on both sides, what we need to do is we need to add 5 on both sides. Add 5. So the 5's will cancel. 8 plus 5 is 13. Is less than or equal to x. And then again, we're using the word or. So on our number line, we have a solution set of 13 and negative 1/5. So again, I'll just start with negative 10, and I'll go up by 5s. Negative 5, 0, 5, 10, 15. And if I wanted to, I could fill this in. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that I can see where my tick marks will go. So we go from negative 10 to negative 5 to 0 to 5 to 10 to 15. So now I'm going to have x is less than negative 1/5. And negative 1/5 is between 0 and 1. Or 0 and negative 1. And again, since it's x is less than negative 1/5, I'm going to have an open circle. And then x is less than negative 1/5, I'm going to go to the left. And then we have that x is greater than or equal to 13. So I go over here, and I have 10, 11, 12, 13. And at 13, it's going to be equal to, so that means we have equality at 13. So again, above it, I could write that at 13. And at x is greater than or equal to 13, I can go to the right. And then there's my graph. Now let's move on to part D. Part D says x, or 10, is greater than 3x minus 2, or x is equal to 4. So let's go through and solve our first inequality. 10 is greater than 3x minus 2. So then what we need to do to get x is we need to first add 2 on both sides. So we get 10 plus 2 is 12 is greater than 3x. To get what x is now, we have to divide on both sides by 3. Divide by 3. And we get that x is less than 12 divided by 3 is 4. And then it also says, or x is equal to 4. So we also have, or x is equal to 4. And if we combine these two together, we have that x is less than 4, or x is greater than 4. So we can combine these together and say that x is going to be less than or equal to 4. And then if we would combine this together, since we combined this together, on our number line, so again we have, I'm just going to put 4 in the middle, and go up 5, 6, 7, 8, and then go down 3, 2, 1, 0, negative 1. So x is less than or equal to 4, so since we do have equal to 4, at 4, we're going to have a colored in circle, or a filled in circle, or a closed circle. And x is less than or equal to 4, we're going to go to the left. So we're shading to the left. And now we have the graph to our inequality. So now if we move on to part E, if we look at this, we have x minus 2 is less than 4, or x minus 2 is greater than 4. So let's go through and let's solve this. We have x minus 2 is less than 4. And now to get x in this case, we have to add 2. Add 2. So we get that x is less than 6. Now let's look at or x minus 2 is greater than 4. So we're going to have x minus 2 is greater than 4. And then to get what x is on both sides, we have to add 2 on both sides. So add 2. Add 2. So we're going to get that x is greater than 2. And again, we have or. So down here we're going to write or. This would be 4 plus 2 is 6, not 2. And if we look at this, we have x is less than 6, or x could be greater than 6, but x can never be equal to 6. So basically what this is saying, it's the same thing as just saying that x is not equal to 6. And if we look at this on our number line, so again we have 6 in the middle, 7, 8, 9, 10, 5, 4, 3, 2, 1. So x is not equal to 6 means that at 6 we're going to have an open circle. And then since it's not equal but it can be greater than 6 or it can be less than 6, we go and shade in both sides. So we can shade in to the right of 6 and we can shade in to the left of 6. Okay. So now let's look at f. F says x minus 2 is less than or equal to 4. So we have x minus 2 is less than or equal to 4. To solve this, we're going to have to add 2 on both sides. Add 2. So we'll get x is less than or equal to 4 plus 2 is 6. So x is less than or equal to 6. Then we have that x minus 2 is greater than or equal to 4. So if we add 2 again on both sides, add 2, we get that x is greater than or equal to 6. And again, we have and. So if we have and, let's just read it. It says x is less than or equal to 6 and x is greater than or equal to 6. So this can happen for all real numbers. So our solution set, but if we look at this, x is less than or equal to 6 and x is greater than or equal to 6 will only happen when x is equal to 6. So x is less than or equal to 6 and x is greater than or equal to 6 means that x has to be equal to 6. So now let's go through and put it on our number line. So we have 6, 7, 8, 9, 10, 5, 4, 3, 2, 1. And x is equal to 6. So we have equality at 6. So we just fill it in. And then we don't have to shade anywhere else because x is just 6. Okay? So now let's move on to our next exercise. Our last exercise here. So we have solve each compound inequality for x and graph the solution set on a number line. We want to pay careful attention to the inequality symbols and the word and or the word or statements as you work. So let's go through and look at this first. For a, again we're checking, we use or. So we have 1 plus x is greater than negative 4 or 3x minus 6 is greater than negative 12. So looking at this, let's solve the first one. We have 1 plus x is greater than negative 4. And then on both sides, we're going to subtract 1. So we get that x, the ones will cancel, is greater than negative 4 minus 1 is a negative 5. And then it says, or we have 3x minus 6 is greater than negative 12. So then on both sides, we're going to add 6. Add 6. So then we get that 3x is greater than negative 12 plus 6 is a negative 6. And then on both sides, what we need to do is divide both sides by 3. Divide by 3. So we get x is greater than negative 2. But right now we have x is greater than negative 5 or x is greater than negative 2. So if we look at this, we know that with or, either one of these could be true. So if we look at this, x has to be greater than negative 5 and x has to be greater than negative 2. So let's look at this on a number line. So let's just start with negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and a 0. So if we look at these inequalities, so we know that x has to be greater than negative 5. So at negative 5, we want to be greater than negative 5, or we want to be greater than negative 2. This has the same thing as if we just said that x has to be greater than negative 5. Because if x has to be greater than negative 5, and we shade to the right, we could see that it's the same thing. It would be true once we get past negative 2, that each one of these x's to the right of negative 2 would also be true. So we could just say that x is greater than negative 5, or x is greater than negative 2, is the same thing as if we just graphed x is greater than negative 5. Okay? Now let's look at b. b says 1 plus x is greater than negative 4, or, so again we're using or, 3x minus 6 is less than negative 12. So let's go through and solve this first inequality. 1 plus x is greater than negative 4. On both sides, to get what x is, we're going to subtract 1. Subtract 1. So we get that x is greater than negative 4 minus 1 is going to be a negative 5. And so let's look at our second inequality. We have 3x minus 6 is less than negative 12. So now on both sides, what we're going to do is add 6. Add 6. So we're going to get that 3x is greater than negative 12 plus 6 is a negative 6. And then on both sides, what we're going to do is divide by 3. And now we have what x is. So now x is going to be less than negative 6 divided by 3 is a negative 2. So now we have our answer. But we have x is greater than negative 5, or x is less than negative 2. And again, we have or. But looking at this, if x can be greater than negative 5, or x can be less than negative 2, let's look at our number line again. So we have negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. So looking at this, if we want x to be greater than negative 5, we'll start at negative 5 and we'll go to the right. Or we want x to be less than negative 2. So if we start at negative 2 and go to the left, we realize that x is greater than negative 5, or x is less than negative 2 will work for x can be any real number. So what we gotta do is just fill in our number line here. And going in both directions. Because since x can be greater than negative 5 here, that means that at negative 5 we go all the way to the right. Or we have x is less than negative 2. So at negative 2 we go to the left. So it covers the whole number line. So x can be any real number that we want. Okay? And then our last example that we have 1 plus x is greater than 4, and, so now we're using and, 3x minus 6 is less than negative 12. So here I have 1 plus x is greater than 4. And then on both sides, what do I need to do? I need to subtract 1. Subtract 1. And then I get that x, because 1 minus 1 will cancel. We'll get x is greater than 4 minus 1 is a 3. And now we have our solutions for that inequality. Now let's look at our other one. We have 3x minus 6 is less than negative 12. Now to get what x is, we need to add 6 on both sides. Add 6. So we get that 3x is less than negative 12 plus 6 is a negative 6. And then what we're going to do is we're going to divide by 3 on both sides. Divide by 3. So we get that x is less than negative 6 divided by 3 is a negative 2. Okay. And then there's our solution.